Welcome to your classes, your TAFE classes, your vet engineering drawing class. So we're doing engineering and we're doing drawing that's going to help you make your products in engineering correct, but also so you know how to read a document properly and you know how to draw a document properly so someone else can read it and make your product that you've designed. So I hear that you've done a little bit of drawing at school. Jessie, is that correct? Can you tell us a little bit about your experience?
No, I don't remember it. It was too long ago.
Okay, so you've forgotten. Did you ever do technical drawing when you were at school, or have you done anything since? Okay, so I'll start at the beginning. So what we're doing at the moment is we need to be thinking about a few things. So first thing I'm going to tell you what we're going to have a go at drawing. We're going to be drawing a cube. And it's going to be, we're not going to do the whole jug, we're just going to do the sides and the top and the bottom. So you're learning about doing an isometric drawing. So an isometric drawing is a drawing that has 30-degree angles that are parallel to each other, and all the lines that go up and down are at right angles to the base. So it's quite an easy technique to learn, but to do that properly we've got to learn a bit about the drawing language, and we've got to learn a little bit about what and how you might apply that later. So this is an example of the jug drawn as an isometric drawing. And as you see, if you compare it with the two-point perspective, the two-point perspective drawing looks a lot more natural than an isometric drawing. Because the isometric drawing, as I said, all the lines are parallel or vertical, going straight up and down at right angles. Anyone think of a reason why you might draw it like that, as opposed to like that in a technical drawing?
For a reference.
Okay, so for reference, what sort of things would you be referencing?
3D models.
3D models, okay, so your 3D models, your 3D, if you're going to produce that object, you can measure those measurements, and then when you actually make it, they will match. Whereas if you measure the front and the back here and you make up this jug as a perspective, that you'll find that your jug is actually lopsided and out of shape and not actually a cube or in a rectangle type shape. What you often then take your drawings in technical drawing, which we won't do, but I just want you to know where they might lead to, is then moving into doing things that are what we call orthogonal drawings, where you draw each of the products from each angle. So that angle would be the same as that one. The one on the other side is that one there. So you're drawing your angles so that you are looking at them flat on, and we're going to consider that when we're doing our piece of work. I think I've gone the wrong way. Okay, and then these are the side view of the same jug and the front view of the jug. This person's been designing patterns that they might put on if they were doing a glaze with it. But basically what we're looking at is, we don't want to do a perspective, we want to come back and do an isometric drawing, which is our starting point. So there's two things you're going to be learning here in terms of using your rulers, using your set square, using equipment correctly, and how to make it fast and quick and accurate. The other thing you're going to be learning to do is fill in your documents and your forms. And I've given you two different pages, because the language that's used in this is really important, and these two forms are slightly different that you might use for different types of drawings. But this one here is more open, hasn't been as quite specific, but talks about sheet, which means often you have, like I just showed you, a variety of drawings. You have a number of drawings in a series, so the person manufacturing it knows how to, each of the different parts they might need to know more about, they can check it off against that. So you need to know how many in the series in case you're feeling like you're missing a drawing. You might go, oh, I need to find another drawing. The date it was done, okay, the name of who actually produced it's a good thing to know. The title of the drawing, so what are you actually drawing? So today we're drawing an isometric drawing of a jug. Okay, but we're going to be doing a cube rather than a jug. And the scale. So are we doing the scale 1 to 1? So are my measurements going to be the same as the thing we're actually looking at? Or am I making it a lot bigger or a lot smaller? So we change those scales. This one here though has a little bit more information, this document. So learning the language here also includes the item number. So anyone know why we might include an item number if we were drawing designs for making something from?
For multiple versions.
Model versions, yeah, that's a good one. That would be the sheet number.
Okay.
So the item number is how many items might you need to do to actually make that product.
Okay.
So if you were doing it for, and you obviously haven't manufactured things using engineering, if you were doing a cantilever toolbox, like my students do in engineering, they need to have drawings that are going to show how the product's going to look when it's finished, with measurements and scales and sizes, so their designs become quite complicated. This one here, I'm going to give you a copy of this each to look at a bit closer. This document here has what we're going to draw today as an isometric drawing, but it also has a different shaped object that's more complicated, and it shows the different ways that you'd be drawing it as an orthogonal drawing. And that means that if you were actually doing the information of item number, you might go, I have two pieces that are that shape, two sides, and if it was this product we're making, we would have 4 sides that would be 8 by 10. Or what we normally do when we're doing engineering is rather than going 8 by 10 centimetres, we go 80 by 100 millimetres, because engineering is normally in millimetres. So I just want to be a little bit clearer, so we're going to bring a little bit of maths into what we're doing. I'm going to bring a little bit of new language into what we're doing. So ask questions if you have any at any time. Just put your hand up so I know. The other thing you need to know is we have 2 different types of set squares. So these 2 different set squares, this one is, anyone know what this one's called? An equilateral triangle, so we've got 90 degrees, 45, 45, so that one's the same at each end. This one here is a 60 degrees on this side and 30 degrees on this side. When we do isometric drawings, we normally do them at 30 degrees for all our angles, so they come out the same. So we only need this one for this particular drawing. Sometimes I've had students when they're learning and they're doing things quite complicated and they want to learn how to put it together without worrying about the angles. They get the isometric drawing paper. And they can draw literally straight onto it, and the lines they're drawing will match the same angles as the isometric square. So this just lets them be able to do that, and sometimes problem solve more complex designs when they're learning how to use the tools to do the other drawing. Okay, the other thing I want you to have a look at is what square you've got. How are your numbers? Are they in 10, 20, 30? Are they going up to 100? Are they 1, 2, 3, 4, 5? What sort of measurements are they in? So when I look at different ones, this one here I've got goes 10, 20, 30, so it's in millimetres, same as this one. This ruler here is in centimetres. So sometimes when people are using technical drawing, they'll use a set square that's got centimetres. Other times they will use one that is in millimetres. So normally as an engineering drawing, we always draw in millimetres. So if we're talking about building something, 10 means 10 millimetres or a centimetre. So our scales, sometimes our numbers seem quite large that we're working with, as opposed to doing 12 mils, calling it 1.2. We want to really try and make sure that we're sticking to that language, which is the engineering drawing language. So, Jessie, would you rather have one that's got millimetres or centimetres on it? And what's the one you've got in front of you?
I've got millimetres and centimetres.
Okay, give us a look at the numbers. Does it go 10 to 20?
It's got millimetres on it.
Yeah, so we'll work with that because that's going to be easier for you. Because I'm going to talk in millimetres as opposed to centimetres.
Okay.
What about me?
It's just the same thing, but with a 0 on the end.
It is exactly the same, except we talk in millimetres in engineering when we're doing doing technical drawings and engineering. So we can keep these nearby. What I've got is your two different pages. So I suggest that we actually will draw our first drawing on your page that has the item number, and we'll actually write the item number and the measurements for those numbers as if you were getting those pieces made to be welded together and you were actually going to make those pieces. I'm just going to move my little jug so I don't break it. And I'm going to take down this drawing because that's not the kind of drawing we're doing. We're doing an isometric drawing, but we're just doing it as a cube. So I'm going to move this drawing out of the way. I'll put it over here on the chair. To remind us of where we're going, this is not the one we're doing at the moment. Okay, so what you'll first of all need to do is you've got your board and you're going to need to get a little bit of tape. So you want the page, you've got two different pages in front of you. I want to choose the one that says item at the bottom here because, as I said, we're going to write that information. And then I'm going to get you to get a little bit of tape each. And I'm going to get you to line your page up level with the top of the page there. So when you put your tape on, I'll just show you on this first one, so make sure it's not any further, make sure it's right on the corner. You don't want a lot of tape on it. I want you to tape your page at the top. Try and stick it a bit further away if you can. And then you take the page out from underneath because you don't need the other page at the moment. And then tape the bottom corner as well. You need to move that right to the top, so it's the right level with the top. It's okay if it's on the floor, can't fall any further. And then you want to keep popping that on, so you want them right at the top. Do you know there's a reason why we're putting it right at the top?
So it's square?
So it's square, yeah, exactly. So I'm going to do the same with mine. I'm just going to use these clips. Sometimes I find the tape actually comes loose. If it comes loose, it could be a problem. But for you, putting these clips on can sometimes make it sit really strangely. So I'm hoping that it works properly for you since we're not in a normal classroom. Once you've got those set, I actually haven't got a T-square, so I'm going to have to borrow one of your T-squares in between. This is actually your T-square. Your T-square is this. These are plastic T-squares. Looks like a T. They're not designed for bagging. They're not designed for doing anything except treating them in good condition. And the same as these, if you start flipping these around or spinning them on your fingers, you will end up with broken ends, and broken ends mean that you can't draw to the end, so they're no longer useful. So do take care of your equipment and it will last you for years, as most of mine here has. Okay, so first thing we're going to do is we're going to draw this. The first thing we're going to do is we're going to give ourselves a baseline to work from so we know where we're starting from. So I'm going to show you where I think we'll start about 1/3 down from the page, top of the page. And I want you just to bring that up. If you bring it up about the thickness, so the thickness of the T-square at the bottom of the line, and then you draw your line across. And if you can do that first line in place, so come up to the bottom of that, in line with that, and then draw a line across that section. It doesn't have to go all along, it's just a guideline, it just has to be light. It's just so you know, have a spot you know you're working from. The next thing you're going to do is, we need to get, so we're doing our cube, we need to get this angle here, which is always at what?
90 degrees.
90 degrees, excellent. Okay, and this one here in particular is actually really good set square because its measurements go right to the edge, but they cost $12 each. So, right here. So you can actually use, if you don't have a T-square, you can use the edge of your page to line up. It's sometimes more difficult. Okay, I'll give you this one back because you're learning. Okay, and I'm just going to borrow this square for a minute. And what I'm going to do is I'm going to come across to my line. And our first line that we're going to do, so I'm going to come across to about 30 for mine. You might find you have a different number you prefer. In fact, I'm going to have to do this a little bit differently because my squares are too big for my page. No. Okay, I'm hitting the top here because I've got an art easel. If I move this across, I might be better. Okay. See if this will work. Sorry about that. This is what happens when you're teaching in a non-traditional setting. Okay. So the first thing I'm going to do here is bring this up, and this always has to be sitting tight there. If you can't read your numbers, just have a look over here, guys. If you can't read those numbers, if you find they're upside down, it will not work. Stop, just have a look for a minute, I haven't quite finished. This is not on an angle. You see how this is tapered and it is skinnier at that end? This side only is a right angle. This side here is not a right angle. So if you flip it the other way and you use that, all your drawings will be completely incorrect. And you'll have to redo them. So that's not the way we want in our TAFE course. We don't want to have to redo it if we don't have to. So if you come across, and for me I'm going to about 19, you might go to about 30. I'm going to line up. One thing you have to check carefully, just stop for a second, just stop and look for a minute. This set square, the numbers start about 5 millimetres in from the bottom. The one you have got, the numbers start at the bottom. So you can literally, if you've got one that starts at the bottom, you can put it there, put that right on the line, and then you can literally measure your line straight up from there. If you have what is more common, one that has a measurement, you have to make sure you're measuring from the 0, or in some cases ones like this that just have a line where the measurements start from. Otherwise, if you're not measuring from the 0, you're actually going to end up with your measurement being incorrect. So we're going to bring this up, line it up tightly, make sure, depending on the square you're using, and we're going to draw a line. We're going to draw our first vertical line 10 centimetres, but how many millimetres is that?
100.
100. So we're going to do it 100, and we're going to do a little tiny line going straight out from that line, because that way we know it finishes. If you do it that way, you can't see how big the line is. Okay, so I'll give you that back there. So remember, measure from 0, or where the line starts on the line. Draw your line up, and it will be 100 millimetres. What we can come back later on and do is we'll actually do some measurements and scales around that drawing, but first of all we'll get the drawing done, and then we'll come back and show how we can identify where it comes from. Okay, now I don't need to use my set square as much, my T-square as much, because I actually have a line, but you can hold your T-square there so that it holds it straight, so you can actually use the T-square if you've got one and slide it up. So when you actually put this on to draw your next line, it just sits on that line sitting in nice and snug, and you can position it, slide it in and out, and it'll work it pretty easy from that. So my next line is going to be 80 millimetres. Okay, so we're back to this next stage. I might have forgot to zoom out before. We're right now. Okay, what we've got to do now is we've got our first line in place. Lucky I noticed the camera had stopped. We can, like I said, you can either use your square there, or you can use it with the line at the bottom, because they've all been lined up to be accurate. You can, if you want to, as long as your line's exactly on there, draw this line up from that way, and then come back, turn it around and measure your 80 millimetres. Once you've got your first two lines in place, and they're a bit difficult to see on this board, what you can do when you've got a T-square is literally slide it across and up, and if you line that up with the 20 that way, I can come back 8 millimetres, and then I can flip it over, and I can then draw my line in, moved, draw my line in the other direction. So this will show you how quick you can get your cube done. Then you come back to where your 80 is, flip it over, draw that line in place, slide across, draw your next line in place, and once you've got that, you haven't had to do any more measurements since your first lot. You literally then, all you've got to do is slide this into position. That's why it's better when you've got tape than what I've got there, the little clip. Okay, you're going to put that one up that direction, and then you're going to do this one in the opposite direction so that it sits across there. And you've got all your parallel lines. Now I'm going to give you this back, and I'm just going to go quickly over mine with a dark marker so you can actually see it. But at the moment you can't see any of my lines that I've drawn from a distance. This will just stand out. Can you see what I've drawn here in pencil? Anyone have an idea why we do this in pencil and not normally start off in a marker like I'm using?
So that you can rub it out?
Yeah, because you will do lines that extend beyond what you want, and neatness is really important. So when I split before, I really need to make sure that that is rubbed out, because if the marks remains, then the person who is going to make that product is likely to think that that's a part of the actual design. So some people even measure down from the top like I have there. So how long are our vertical lines? How long are these lines going straight up and down?
100 mil.
100 millimetres? Great. And how long are our lines going in the other direction?
8.
80.
80 mil.
Yeah, 80 mil. So we don't, have we got a true cube there? Have we got a cube that's the same on each side like a dice? No, because we've got a 12 one. Because if you look at this, I've tried to keep the dimensions the same as a jug, so you've actually got a 3D example. It is the same at the bottom, but it's taller and narrower. So that's why I changed all my dimensions from a cube, because I actually had an example. I find if you can look at something, it's easier to do. So what we're going to do here is, how are your drawings looking? This is going well, great. You're just going to do the next one, so that will just slide in. So once you've got that one, that will line up properly. Again, these are looking good. If I do a quick check of your angles, they're all correct. You've actually followed, it's very accurate, that's well done. Give us a look at yours.
It's not quite perfect.
It is right, it's correct. It's actually great.
It is perfect.
No, they're accurate. Where you've got little bits, what you're talking about is the bits that actually hang over the edge. We just rub them back at the end before we submit it. Okay, what we're going to do is come back to a bit of language. So you've worked on your measuring, okay? If you are doing this and you want to do it for dimensions for someone to make, and actually make this product, I'll do this in this pen, because I think you'll be able to see it better, but normally you wouldn't do it in a pen like this. So normally if you're doing it in a pen, you would extend these lines out a little bit that you've got, but you don't want to touch the actual object. These are your ones to show your measurements. So where you've got that line, you can use this a bit like a ruler, you just come out a little bit further in this direction, and then you also need to come out the same. So if I'm doing that again, if I just try and do it by guessing, I'm not going to be as accurate as if I come through with this. And I just draw a little line out that way. Then I'm going to flip this over, and I'm going to draw, this is my dimension, so I'm knowing what dimensions I've done. So I'm going to go down here and leave a little space. In the middle here I'm going to write 80 millimetres. Okay, engineering drawings, if you leave off the millimetres, people expect it to be millimetres. So that gives you that dimension. And then I'm going to do the same for the height. And then the only two measurements I need to do, because as we found, every other measurement is exactly the same. And then I can come back with this and mark in my vertical line. Now, why am I using a ruler when I'm doing those and not just freehand drawing these?
To make sure it matches.
To keep it neat and keep it really regular. We don't want technical drawings where we're just hand drawing. If we're actually doing a sketching out to show somebody what you're talking about, you might sketch it out. But when you're actually presenting them with the drawings to actually work from, working drawings, you want to give them all the information that will make making that product easier for them. And once they know that, we're going to not have to write lots of different things because we're going to write them down here in the items list now when we're talking about our product. So I want you to have a go at doing that, and once you've got your key measurements, I'm going to write down, we're going to work through together as to how we're going to write up the language we need in our chart. So you need to come back and do these. You need to show this line, so you're going to be starting with this line coming down here, extending that one coming through. So this one, yep, you're doing that one. Great, so you need to just also come out from here. So the easiest thing to do is just bring this straight up because that will slide up. So the more you can use the T-square, the easier and quicker your drawings are. So this is one of the requirements in that drawing, interpreting drawings and technical drawing unit that you're doing, that you also need to be able to use a T-square in a drawing board. Be able to understand how to read a technical drawing as well as do a technical drawing. Okay, these are good. Doing a good job with these. Once you get used to sliding it, it becomes quite easy. But if you don't keep it in tight, you don't follow it, and you might need to rub out this little section in the middle because you actually write your measurements in between the lines. If, for example, you were showing measurements of a smaller spot, you would actually put the lines, arrows pointing in if it's a very small space and you have no room to write. So you're actually showing that there's a dimension inside that space. Okay. Next we're going to do our labels. So when we're labelling, the material we're going to make our product out of is going to be 1.8 steel. Okay, so we're going to cut it out of steel. Okay, the date today is the 6th of the 5th of 21. Okay, and we're going to talk about our scale. So we've drawn this, and we've drawn this to scale, or we made it bigger or smaller than it actually is. Is that to scale?
To scale.
Yeah, so we measured that, we'd find it's the scale. So when we do the scale, we're going to do a 1.1. If we made it half the size, we'd do 1.2. If it was a quarter the size, 1.4. And the same if we were making it as a very small product and we were doing the drawings bigger, we would do it the opposite way round. Okay, so at the moment the size is actually A3, so the drawing's in A3 page. Title of the firm is Learning. That's the name of the business we're doing it for. And the title of the drawing is really important, so we're going to call it Isometric. So this is our Isometric. So there are isometric drawings. So this is a bit of that new language we're learning. Now, this is the one where we're going to be doing it as our working piece. This little section here is left plain. That's a great spot to put your name. So write your name because you're the designer. So write your name on that page to go with it. And then I'm going to do the materials list. So we've got the material, we need to work out how many items we're going to make. So if we're going to make this product, how many are we going to need? So the top is 80 by 80, isn't it? So we're going to do 80 by 80. And so that's telling us how many do we need on a cube that's 80 by 80. How many of these do we need? 2? Yep, so we do 80 by 80 in this box, and over here the quantity is we're going to cut 2 of those, 80 by 80. So if we're going to make this in steel rather than ceramics, we're going to cut 2 pieces, one to go on the bottom and one to go on the top.
Are we talking about the cube or are we talking about the thing?
If we're making this cube that we just drew in steel, so I've said we're going to draw making
so
steel.
80 by 100 we're making 4.
Yeah, 80 by 100 we're making 4 for the sides. Spot on. I was going to say, who can tell me the next? So you've got that one right. So 80 by 100, and we have 4 pieces. So to make it as a cube, that's all the pieces we need. Okay, any questions? Okay, let's go over what are the key language that we learnt today.
Isometric.
Isometric. So what angles are isometric drawings done at?
30
Okay.
degrees.
30 degrees. Okay, so 30 degrees, yep. So how do we get 30 each angle? We have to flip our set square. Flip our set square. Have to use our set square. We also have to remember we have to flip it
We have to flip the set
often
square.
to get it into position that we want.
Yeah.
So we often can't just do it one way.
To flip it, we have to
Okay.
use.
What are the other angles we need to know? What's the other there's only two angles, 30 degrees, and what's the other angle?
90 degrees.
90 degrees. Okay, what's the measurements in when we're measuring for engineering drawings? What
Millimetres.
Millimetres, great. So if we don't write millimetres, which I didn't write there, and we don't write them there, we know not automatically as an engineering drawing it will be in millimetres. Okay, here it says sheet. We've only got one drawing in this set at the moment, so we would have one of one. But normally you'd be doing a whole series of different drawings, like I showed you those orthogonal drawings of the jug, and you might end up with 2, 3, 4, 5, 6 drawings that are part of the set for someone to make this product with more information,
Sensational.
which is like I was showing you on that other design. Now, what is this paper called that we've drawn on? I don't know if I've told you that. So it's technical drawing paper which is set up with different information boxes. So the boxes are not always the same and they're sometimes positioned in different places depending on the designers who's making it. But the information that has to go on them is fairly similar in most situations. It can change a little bit. Why do you think we have a date on it?
Help you trace it.
Help you trace it. So often, you know, I might come back into the factory that you're working in and say, look, I got something done about 5 years ago. Can you have a look and see if you can find that design? I need 5 more of those, please.
Tracking and tracing,
So,
very important.
Dates are important, and also too, in case someone's modified the drawing and you're actually doing the later design, not the earlier design. So normally you try and identify which design it actually is, because as we know, if you've ever built a house, that most people will change things. Any other questions?
Nope.
No.
Okay, so we've done a very good lesson, thank you. And you can help put your equipment away and make sure everything's labelled. Thank you.